Hello everyone and welcome again to my latest episode of my Rust Quickies. In my last quickie I have talked about variables in Rust, and today I want to talk in more detail about arrays and how you can work with arrays in Rust. An array in Rust is always defined with square brackets. As you can see here, I have used here that syntax, and inside the square brackets you just provide the individual values of that array with a comma separated. I have defined here two arrays. One array databases, which just contains string values of a few major database systems, and I have here another array called prime numbers, where I have some integer values which are representing the first few prime numbers. One very important point about arrays in Rust is the fact that you can't change an array at a later point in time. Means the individual entries, the amount of entries that you have in an array is always static. So in those both arrays you are not allowed to remove an entry or maybe adding an entry at a later point in time. An array is always static in Rust, and this is also because an array is always allocated on the stack in Rust. Means when we are allocating those two arrays here, you are not allocating here space on the heap. No, you are just allocating those arrays on the stack. After we have defined those arrays, let's work with those arrays a little bit. First of all, every array contains a function called len, which just returns you the number of entries that you have in that array. And as you can see, I have defined the array databases as mutable. Means you can change that array. As I've said, you are not able to remove an entry from that array or add a new entry into that array. That's not allowed in Rust. In my next quickie, I will talk about vectors, and with vectors you have that possibility. But because we have defined that array as mutable, we can call functions on that array which are changing that array. For example, I'm calling here the function sort so that we are getting a sorted output. And then I'm doing a for loop across that array, and I'm just printing out the sorted database names, and we are doing the same here with my array with the prime numbers. So let's run that. Let's do a cargo run command, and as you can see, we have here our sorted arrays of databases. We have 4 databases in that array. We got that information from the length function, and you have here the first few prime numbers from the prime numbers array. And as you can see here in the next step, you can also define an array in a different way. As you can see, I have defined here an array with numbers of ones. So you specify in the first part of your array declaration that you want, for example, the number 1, and you want that number in that array, for example, 1000 times. So it's very easy to initialize a larger array in Rust. And as you can see, when we call here the length function, you can see that we have 1000 times the number 1 in that array. So this is just a different way how you can define an array of values in Rust. As I have said previously, an array is always allocated on the stack in Rust. So you're not allocating any memory on the heap when you're defining the content of an array. But this has now some serious side effects. Imagine you're allocating a huge array. You would allocate a lot of memory in your current stack frame on the stack. Imagine the following. I'm defining here a very large array. In some we're allocating here for that array 8 megabytes of data on the stack. And guess what? That definition of that array causes a stack overflow. So when we try to run that program now with the cargo run command again, you will see that we have here a stack overflow. So we have here a stack overflow. And therefore our main thread, as you can see, has overflowed its stack, so it was just terminated by the Rust runtime. So this is also very, very important to know. You're always allocating arrays on the stack, and therefore it could trigger a stack overflow, and that stack overflow just terminates your program. So very, very important to remember here. In today's Rust Quickie, I have introduced arrays to you, and one of the takeaways from that Rust Quickie is that an array is always static, and the content of that array is therefore always allocated on the stack. In my next Rust Quickie, I want to talk about so-called vectors, and as you will see, vectors are dynamic in Rust, so you can add some content at a later point in time to a vector. You can remove elements from a vector at a later point in time, and a vector is also allocated always on the heap. So thanks for watching this Rust Quickie, and I'm already looking forward to see you next week again. Thank you.